Well, hi, everybody. Welcome back. So last time we covered naming objects and really the idea of organizing our projects in RStudio similar to the way that we would think about writing an essay in an English class or in a language and rhetoric class. And that goes from decomposing the components of the code. So we've got functions, which are kind of like verbs, they do things. And then we've got arguments and of these functions, which are like the inputs to the function. We usually think about those as like maybe nouns of some kind because they're often pieces of data or they're sometimes we can think about them as adjectives because they are parameters that control how the function does what it does. So I'll give the example that Tammy hit the ball hard. So the word hard in English is an adverb that describes how the ball was hit. And so we can think about the arguments of a function similarly in that they will often control the behavior of the function or they modify the behavior of the function. And then we wrapped up by creating our very first RStudio project. Now, this is something that for the rest of the class, I want you working in a project because it's going to help you keep your files organized. And I know this is something that you should have been working on over the past couple of days is organizing your computer into a project-based organization so that you have all of the files related to a particular task or a particular thing that you're working on next to each other in the computer in a directory structure. And so that's a review. This lesson, we want to move forward and we especially want to make sure that we understand that this lesson is getting into how R works and why R does what it does. So for many years, this course had been called Advanced R, and that was confusing to some of the students because they were asking, well, where's beginning R, where's intermediate R? It was called Advanced R because a lot of the material was drawn from a textbook. This class, when I first started teaching this class, it was primarily focused on lessons 6 and 7, and it was a shorter course. It was about maybe 4 or 5 weeks. And I went through some basics of ggplot, and then we dug into like how the data structures work in R because I had found that a lot of the people that I was consulting with at the hospital at the cancer center, whenever they were using R, they would get tripped up on how R thinks about data and how R structures data. So, and then the other thing is that everybody wanted to learn how to make ggplot, how to make graphs in ggplot. So, when this class started, oh God, it's long time ago now. It was primarily those topics. It was number one, how do I make graphs, and then number two, how do I understand the data structures in R? And so at that time, because it was focused a lot more on understanding the data structures in R, which the material for that comes from the Advanced R textbook, this class was called Advanced R. But over time, the more I had focused on adding more and more data science components to the course, then we shifted and pivoted and added more and more material from a textbook called R for Data Science by Wickham and Grolemund. And so the class ended up being renamed from Advanced R to R for Data Science because now it's probably like 60 or 70% information from the textbook and R called R for Data Science and about 30% the Advanced R textbook. The stuff that's quote unquote Advanced R is going to be these two lessons right here, lesson 6, lesson 7, and then down here, functions and control flow, this lesson 11. This material is more heavily borrowed from the Advanced R textbook by Wickham. So that's a little bit of the backstory. So I want you to understand that this lesson, lesson 6 and lesson 7, and also lesson 11 later. I think lesson 11 is probably conceptually the most challenging material in the course, but lessons 6 and 7, they can often the material is often, well, I'm hoping that the way that we cover it is not confusing, but when I'm interacting with folks who are new R programmers, these are some of the places where they get stuck on. And I want us to understand the different data structures. And this is it can be challenging, especially if you've never written any computer programming languages before. So let's dive in. I believe I've mentioned this before, but I worked with an organization called Software Carpentry and Data Carpentry, and there was a lesson that I contributed to called the R for Ecology lesson. So some of the material in this class is borrowed from that lesson. So credit to the amazing authors at Software Carpentry and Data Carpentry. It's a good organization. It helps people learn. So here's what we want to go over in the next couple of videos. And that's going to be, what is an atomic vector? And then how do I subset an atomic vector? How do I get pieces out of that vector? And then what's going on with this thing called type coercion? And then we also want to talk about something that a little bit more advanced, and that's the attributes of an atomic vector. So the attributes of an atomic vector themselves are not atomic, which right now at this point in the class, that probably makes absolutely no sense to you, but we'll cover that in detail over the next couple of videos. And then getting into a little bit on factors towards the end. And anyway, so as a review, please remember that everything in R is an object. So I want us to go back to, I don't know if you have seen this before. I think I might have shown you something similar to this. But so far, we understand that everything's an object. And you've got objects broken up basically as nouns and verbs. So all the verbs live over here. These are functions, and then all the nouns live over here. These are vectors. And a vector is not like what you think of when you do maybe a calculus class or a linear algebra class or a physics class, where a vector is like a couple of numbers and they represent like a direction in three-dimensional space. So the vector 2, 3, 3 means 2 units in the x direction and 3 units in the y direction, 3 units in the z direction. So this kind of arrow that goes out from an origin in three-dimensional space. And that would be a vector in mathematics. It's not really what we're talking about here in R. And think about a vector in R as just an ordered set of elements, okay? So I can make a vector of the luggage, like I take a piece of suit, like a suitcase, like luggage, and I can pack that suitcase as long as I could theoretically like assign numbers to each item in the suitcase, then that suitcase is now a vector because it's a collection of elements, and if necessary, I could order that collection of elements based on these numbers, for instance. So vectors, just an ordered set of elements. Now, inside of the conversation about vectors, there's atomic vectors and there are lists, which are the point of the whole purpose of this lesson, or this lesson number 6 on atomic vectors and lesson number 7 on lists. So basically almost all of the data that you will ever encounter is a vector of some kind. And that's because R is a vectorized language. R is designed from the ground up to work with vectors, these ordered sets of information. So let's talk about atomic vectors, and let's finally actually define what an atomic vector is. So an atomic vector is a vector, so this is an ordered set of elements such that each element in the set shares a common type or class. Okay, so if I go back to my idea of a suitcase, I've got all of the items in my suitcase and I've assigned them all numbers, so that makes them ordered, and therefore we have a vector. If everything in my suitcase is all clothes, for instance, like articles of clothing, then they're the same type. So I can say, okay, well, this is an atomic suitcase, if you will. Thinking about it from the R definition of the word atomic. And so if I've got 10 shirts and 10 pairs of jeans and 10 pairs of socks, or something like that, Those are all clothing, articles of clothing. And so therefore I could describe this suitcase and its contents as an atomic vector. However, if I have an article of clothing, so if I've got like 3 shirts, 3 pairs of jeans, 3 socks, but I also have a travel size blender, for instance, and a hair dryer thrown in there. Those are not articles of clothing. So now this object is no longer atomic because I've got objects of multiple different classes. I've got articles of clothing, but I also have appliances, travel appliances like a travel hair dryer, a travel blender, or something like that. So that's kind of what we're trying to wrap our heads around right now is this idea of an atomic vector, and that is an ordered set of elements such that the elements all share the same type or class. So here's an example. We're going to create a vector of weights. So these are animal weights, and we're calling it grams. So I've got 50 grams, 60 grams, 65 grams, and 82 grams. So these are all small animals. And then we've also got, these are all numbers, and we see that, no problem. So all of the elements, so this is ordered. So this is the first number, the second number, the third number, the fourth number. So this is an ordered vector, an ordered set of elements. So this is a vector, but all of them are numbers. So they all have the same type, i.e. numeric information. So this is an atomic vector. Similarly here, I've got an ordered set of elements. So I've got the first element, mouse, the second is rat, the third is dog. There's an ordered set of elements, and they all share the same type. So these are all pieces of character information. So this is another atomic vector. Now, I'm going to take an aside here and talk about the quotes. If you had tried to make this ordered vector without the quotes, just to say mouse and rat, you're going to get an error here. So this goes back to the idea of how do we make characters? We can't just type the name. We can't just type the letters. We have to put it in a character string. Otherwise, R is going to say, oh, there's an object named mouse in the global environment. It's going to look in the global environment to find an object named mouse. And then it says, oh, I can't find an object named mouse, so I'm going to give you this error. Okay. So anytime you see object such and such not found, and you were trying to type character strings, it really just means that you forgot to put the quotes around the word. Okay. So we've already seen the C function. The C function stands for concatenate, and it's one of our tools to make vectors. And if you put all elements of the same type, and like C for it, C is primarily used to make atomic vectors. We can use C also to add numbers to a vector, so we could put a 30 at the beginning and a 90 at the end. And now here's the original weights that we had in the middle, the 50, 60, 65, 82, but now there's a 30 at the beginning and a 90 at the end. Okay, so I think we're going to pause here, and then we'll come back, and in the next video, we'll talk about the atomic classes. All right, see you soon.